few points related to Outlook, of course. We covered hardware basics, some troubleshooting, and operating system, and Outlook. We covered mainly these three topics from last 6 days. Okay. So I think today is the 7th day. Okay. So today is the 7th day. So a day up to day 6, we covered so far all these things about the device drivers and everything is important points, guys. Everything people will ask. So today is 7th March 2024. So I want to cover because this work from homes is no right questions, but still this networking topic is used and it is also an important topic. Okay, so but still it is we'll try to cover maximum of topic. Again, we'll continue. So if possible, Saturday also we'll try to take the class after morning. Okay, I'll take mornings. So here it is today. So our topic is networking basics or networking essentials. I'll try to give a maximum of parts. Okay, maximum network I will try to give you. Okay, some are depends upon time. Will here it is. Topics are related to the networking basics. So what is a network? What is internetwork? What are the different physical topologies we are used in the network? Okay, or different types of networks based on a geographical size or range. Okay, and other different networks. What is SOHO? Small home, small office, home office kind of stuff, and different devices used in a network. Okay, in a simple manner. And of course, we will going to discuss other things like cabling, what are the different type of cables, NICs, network interface cards, how it is look like, wired NIC, wireless NICs, what is that numbers and representations, okay, how to check these MAC addresses, IP addresses, okay, what is that meaning of these particular things, okay. Okay, so what is an IP address? What is uh, simple MAC address and IP address differences? Okay, different devices we use in the network. So what is the purpose of these devices? Where we use these particular devices? Okay. Next one is individual device, their information. And what is about IP address? What is IPv4? What is IPv6? Okay, what is public IP address? What is private IP address? Okay, what are the different protocols we use in the regular communication means? So most frequently, these protocols are important for in our daily communications, right? So those kind of stuff also are listed here. OSA layer, each layer, their importance, okay, and TCP, IP, and OSA layer comparison. Different commands we use in the networking troubleshooting related kind of stuff. How to troubleshoot network using a what we say using OSA layer with the help of OSA layers, and what is other settings we do in this OSA layer. Okay, so this is networking part, and once completed networking part. So we'll see that not it won't be completed in one day. It will lengthy topic. Okay. So moreover, I will concentrate on very main important points. So small points we can see. Okay. So here it is. Okay. So spatial audio or noise suppression on. Okay. So we'll see. And networking and service desk, these two are very important topics. Okay, so of course, what we discuss, everything is important topics only. Again, this networking, service desk, and Office 365, cloud computing, which is VPN. These are very important and most common questions. Okay, so here it is. We start with what is a network. So here it is starts. Interconnection of two or more devices is called a network. Interconnection of two or more devices is called a network. So I have a computer, maybe I have a laptop, or maybe I have a mobile phone, or maybe I have a printer, network printer. So I make a connection. Either I will connect directly, or maybe I will use a switch or a router or a wireless kind of stuff. Whatever it is, so I connected these devices together. Now it is become a network. Now it is become a network. So this is a network. So interconnection of two or more devices called a network. For example, this is device A, device B, device C. So I connected these devices using some hub or a switch or maybe a router or maybe a wireless access point or maybe a wireless router. This is we call it as a network. Interconnection of two or more devices called a network. Next, communication between two or more interconnected devices is called a networking. So what is a network? Connectivity. What is networking? Communication. So I try to communicate from A to B. So there is a communication between A to B or A to C or B to A or C to B. So whatsoever it is, so they can able to communicate, right? So what is meant by communication, guys? So we are talking. So I'm talking, you are also talking, we are asking question, I'm giving an answer. Okay. So we are having a communication, right? Same way, different ways of communication is there. Communication does not mean only talking. Different ways of communication. You access information through website, web related communication. This you download a file from internet, right? So FTP, that is a communication. You are chatting using WhatsApp, okay? So instant messaging, that is also a communication. You share a data, you share a printer, that is also a communication, okay? So you're pinging, just pinging, that is also a communication. You're sending a mail and receiving a mail, that is also a communication. So if you are able to communicate either different ways, communication is there. Even the ping command is also one of the communication. If you are able to communicate from one device, that is communication. So there is a communication between the devices, two or more devices, which is interconnected, is networking. So what is a network? Connection of interconnection of two or more devices is a network. So communication between two or more interconnected devices is called a networking. Guys, understand what is network? What is networking? So I have another network. Very good. I have another network. So there is another network. So these also connected each other. That is one network one. For example, this is network two. So I put a different names for this one A, B, C, D, E, F, and this is a network. Okay, this is another network. This is a network one. This is network two. Okay, I will put it here. This is another network. It is simply represents a LAN network like that. Think like this. So network means it can be two or more devices. For sampling, I put a three devices. So people put a 2 means there will be only 2. It can be 2 or maybe 3 or maybe 4 or anything. Maybe they connected wired or wirelessly. Okay. Okay. This is another network 3. So there are individual networks. For example, I want to make a communication between this CPC to DPC. Okay. C device want to communicate it to D. How can they communicate? There is no connectivity, either wired wise or wireless wise, no connectivity. There are separate networks. Separate networks. So what I'm trying to do is I'm connecting these networks together. So we can able to communicate between the networks. You know what is meant by internet? Networks of network. Internet, networks of network. Okay, I'm adding like this. So you can have a connection like this or may not. So no problem. But to make it to understand, so there is a connection just for our understanding. Okay. Now our C can able to communicate like this. First of all, it will go to this, go to the device like this. Yeah, 1 second. Hello. Hello. What's happened? Um, you know, okay, sorry, guys. Where am I? Yeah, C is trying to communicate it to D. So how it is goes? It has to go outside of the network like this to this device and try to reach which network it is there. So here and then enter into that network and try to reach here. The same way D again replying. So what it will do? So first D goes to outside of the network, then go to search where the network is. The C network is located, then it will reach. This is called our inter network. First one is what is internetwork? It's a connection of 2 or more networks. We created a internetwork. So this is internetwork. This device is internetworking device. The device is internetworking device. Okay. And if you are able to communicate like from one network to another network, that is called a internetworking. Okay. So what is a network? interconnection or connection of two or more devices is a network. Communication between two or more networks is called a internetworking. Okay, communication is networking. What is internetwork? What is internetwork? Connection of two or more devices is called a internetwork. Communication between different networks is called a internetworking. Okay. Guys, understand?
Yes, sir.
Okay. Let's look at here. From F to E or D, they don't need this external internetworking device like router switches, router kind of stuff, modem kind of stuff not required. So they can communicate within the network. This is communication within the network. It is like a LAN network. They are communicating within the network without having any, without going outside of the network. But when you are going to communicate from one network to another network, you must go outside of your network using any internetworking device like a router. So simply say, so this is router. Our internetworking device is router. So this is your hub or a switch. The device is hub or a switch. So where this is a LAN communication, this is outside of LAN, like a WAN or a WAN communication, you can say. So to create a network, what we need a hub or a switch. To create a network, we need a hub or a switch. To create an internetwork, to create a internetworking device is our router. Router is a internetworking device. Networking device. Communication between different networks. What it is doing? Communication between different. So I think you cleared this part. Network, networking, internetwork, and internetworking. So network connection, networking, communication. So again, guys, network. So when any place, if you are here, this thing, network means either it is physical network or logical network. Physical network means connection of devices. So you connected the devices in different ways. We can able to connect the devices. Is a connection of devices. Connection of devices or connecting devices is a physical network. Okay, or physical topology. The way you connecting the devices, we call it as a physical topologies. What is a logical network or logical topology means how you are assigning an IP address or a logical address to the device. So based on that, it is a logical network. Means in a one single physical network, you can have a multiple logical networks. Okay. So like that you can see. So logical network means it depends upon how you configured an IP address. It's a logical address. Physical network means how you connect a device physically. Physically means wireless also same physical topology also. Okay. So here these are went some places. I should why it is went. It's one, two. Okay. So here it is different physical topologies are there, guys. So one is so what is a physical topology means the way you connect devices is called a physical topologies. Important one is the basic standard One is 4 topologies: bus, ring, mesh, star type of topologies. Hybrid is combination of 2 or more topologies. Then it is hybrid. Okay. These are the some other topologies given here. I think we can put this tree here. This is a standard tree, and there is a star. And okay, now what? This is good. Think I will draw anyway. So here it is. You have a device. You have a devices. So we need a connectivity. So physical topology means, so the way you connect a devices is physical topology. And there is a backbone wire. You know, in the olden days, we have a cable TV network. So we use a coaxial cable. We use a coaxial cable to connect. One main wire is there. So they draw a wire from main cable TV station to the houses, that entire street, one big cable. From that cable, there is small connection to each TV. So that is nothing but same concept here. So here also we use a backbone cable. Here it is a backbone cable. This is a backbone cable. Actual signal carries through this backbone cable. From this backbone cable, our devices are connected, means our computers or laptops or maybe like that. Now we are not using. So always we have a computers that time. So our computers, networking devices, okay. So they will connect to this main backbone cable, okay, the backbone cable. Devices connected to a backbone cable. So this type of topology we call it as a bus topology. All devices connected to a backbone. And it is very easy to configure and cheaper solution. Okay, it is very easy to configure. We need a cable and just to take a cable and connect it to cable any device. So connect it to the backbone cable. Okay. So of course they follow some topology, some protocols to communicate within the devices, but simple. Take a backbone cable and connect any new device added, connect it to the backbone cable. It is very easy to install and configure. But one thing is difficult to troubleshoot, little difficult to troubleshoot. What it is, for example, this backbone cable, somewhere it is cable is disconnected. So communication between these devices will be there, and communication between these devices from here to here, no communication. Further communication will start. Okay. So if they face any issues, okay, it's very difficult. We have to trace entire cable where the cable problem is occurred. The cable problem or system problem or any other problem, we don't know. Communication is stopped for certain systems. Communication is there from further systems. No communication from here to there. No communication. Again, you have to enter trace the cable and find out where is the problem, and you have to resolve the issue. Okay. So troubleshooting is little difficult, but installation is simple. And more bandwidth consumption because the entire transaction go through the single cable. So more number of devices increases, the cable size also should be increases. Okay. So that is the problems with the bus topology. Guys, understand bus topology?
Yes, sir.
Here it is. Another type of topology. In this topology, a device is connected to another device. A device is connected to another device, next device. So that device is connected to another device. For example, you put in names for this device A, B, C, D, E. So A is connected to B is connected to C is connected to D is connected to E. Finally, E is connected to A. It's like a circle. It's like a circle or clock direction or anti-clock direction. So a device is connected to a next device is connected to another device is connected to another next device. So finally, last device is connected to the first device. Okay. So here, if I want to send a data, okay, from A to B communication. So I want to do some A to D. I want to send a packet from A to D. Okay. So look at here how it will send. First, it will send to B, B to C, C to D. And D want to reply to A, D to A communication. D send to E and E send to A. Okay. So one way is maybe it is lengthier than reply way. Sometimes it will happens. Okay. So if it is one direction, it is a clockwise direction. So there is a topologies they use in this topology. Yeah, of course. What type of topology it is? Anybody?
Ring topology.
Very good. It's a ring topology. Very good. So what is a ring topology? A device is connected to another device, other device is connected to another device, and finally last device is connected to first device. So it will always communicate either clockwise or anti-clockwise, depends upon the configuration. Okay, depends upon the configuration. So here is also some problems are there. For example, a wire is broken like this. So further communication will stop. From A to B, communication is there, but B to C, communication is stopped. So it won't communicate another side. It depends upon their conflicts. Okay. If device is down, for example, C is down, so A to B communication is there, but no further communication because it cannot reach to D. D can reach A, but A cannot reach D. Okay. So like that. So there is a problem. So they invented double ring topology by adding more kind of stuff like this. Means one path is for anti-clockwise, another path is anti-clockwise. Okay. One path is clockwise, another path is for anti-clockwise communication. So then, which is the nearest way to communicate, even though one of the line is down or one of the device is down, there is a possibility of communication is there with a double ring topology. This is called a double ring topology. Okay. Of course, still there is an issues. Okay. Of course, there is some issues are there. One is if I want to add one more device, it means I want to scale my network. I want to add more number of devices. Okay. Again, I have to reconfigure entirely. So because the path is changed now. The path is changed. So this is the old path I have to remove. And again, I have to reconfigure this new path in all the devices. So that is becoming more difficult things. Okay. Scalability is difficult again because of we are adding a new device. Entire path configuration is you have to do it. Either it is single ring or a double ring. That is little headache. Difficult to troubleshoot also anyway. Difficult to troubleshoot anyway. One way communication is working, another way communication is not working. Again, you have to search where the issues occur. Again, you have to search the location and do it. Larger the model, very difficult to troubleshoot. The 4-5 system, okay, but large models like a 20-30 systems, very difficult to search. Okay, so these bus topologies are may used in earlier days. Nowadays, we are not at all using. And ring topologies also may used in earlier days. Nowadays, we are not at all using. But this is also a topology. Okay, so bus topology and then ring topology. Guys, understand both topologies, how it is? So both are easy to configure, difficult to troubleshoot, and difficult to scale. They have their own issues. So here in this one, every device is connected to all other devices. Every device is connected to all other devices. Okay. So for example, here it is A, B, C, D, E. Every device A is connected to B, A is connected to C, okay, A is connected to D, A is connected to E, okay. So B is connected to A, C, D, E. C is connected to D, B, A, E. Like that, every device is connected to all other devices. Which type of topology it is? Anybody?
Mesh.
Very good. It is mesh topology. Okay. So in a so many people will confuse when they see this star kind of stuff. It is a star topology because their mind knows that is a star topology. Okay, there is a star topology. So obviously, when they see the star, they think it is a star topology. Now, guys, mesh topology it is. So in mesh topology, every device is connected to all other devices. It is highly redundant. Highly redundant. It means if you one path is down, no problem, all other communication is going on. In bus topology, the main backbone wire somewhere there is an issue, so further communication will stop. In ring topology, if there is any connection issue or device issue, further communication will stop. But in mesh topology, if one wire is down, no problem, all other devices will communicate each other. All other devices will communicate each other. That is first one. Second one. If any device is down, for example, one device is down, no problem. Only to that device only we cannot communicate. All other communication is keep going on. So that is why it is redundant. Okay. So it not depends upon all these three topologies. Do not use any external device to communicate. Only with the wire communication only. Only with the wire connectivities, not any external devices we are not using. Again, mesh topology is redundant. Even if a wire or maybe a device is down, remaining communication is going on. But it is complex to configure. It is very complex to configure, very complex to troubleshoot. It is very difficult to troubleshoot also. Okay. So mesh topology, a device is connected to all other devices. Okay. And it is redundant because how it is, a wire or a device in the network is down, further remaining devices will communicate each other, remaining paths and remaining things will communicate. Okay. So, and it is not depends upon any centralized device here, but it is difficult to configure. It is complex configuration. It is complex, difficult to troubleshoot, and difficult to scale. Very difficult to scale. What is scaling? What is redundancy? What is scaling? Ability to increase. So I have a 10 devices are connected. Now I have to increase my network. I have to increase up to 15 devices. That is scalability. So ability to increase. Okay. So now if I put as some other device, so look at here A, B, C, D, E. For example, this is F device. So how many things connection I have to do it? So look at here 1, 2, 3, 4, 5. Okay. So those many connectivities, you have to do it again. You have to go to each and every device, shut down, connect a new NIC, and then put a wiring. Again, new devices came, again you have to do it. So it is very difficult to scale, very difficult to troubleshoot, very complex to configure because a lot of wiring is required. More number of devices increases, more number of wiring increases. Okay, here we have a 5 devices, but if you see the wiring, lot of wires are there. So that is the problem with our mesh topology. Okay. Guys, are you okay up to here?
Yes, sir.
Here is a centralized device called a hub. Okay, or you can use a search depends upon your network size and requirement. And we have a devices like our computers, laptops, or printers, network printers. Okay. We have a devices. You can connect these devices to this centralized device. So every communication is going through this centralized device only. All these devices will communicate to this centralized device only. Okay. So how it is communicate? For example, A want to communicate B or C, for example. So A send a packet, the packet goes to hub or a switch, and it is reached to C. Okay. From every communication, you want to communicate from E to B. Like this only it will communicate. No direct communication. It is all communication going through this device only. Okay. So this centralized device we use that can be hub or a switch. Okay. Depends upon your network size and your type of network. So what type of topology it is? Any guesses? This is star topology. Okay. This is star topology. So all communications from through this centralized switch. What is the advantage and disadvantages? You have to buy additional switch or a hub. Okay, means not just a wires, you need a centralized. Of course, single wires only, so no problem because of instead of putting a cost on more wires, we put in a some device. Okay, and all communications by this switch, if this switch is down, the total communication is down because all communications by through that switch or hub. If the centralized device is down, entire communication is down. Okay, next. If one of the device is disconnected, if one device is there that is disconnected, or a wire is having some problem, or device is down, or a device is down, only the particular device won't communicate. For example, in a ring topology, if C device is down, or maybe there is a connection is down, further communication will start. In star topology, if any wire is down or a device is down, that device or the connectivity is only won't work. All remaining communication is going on. Okay. And remember these 2 points. One is one single wire is down, or maybe a device is down. Only those devices won't communicate to anyone. Remaining communication is going on. But centralized device is down, entire communication will stop. Okay, entire communication will stop. And it is again, I'll say easy to configure easy to troubleshoot, easy to configure, easy to troubleshoot. So how it is easy to configure? Simply you need a switch, you need a bunch of cables, take a device, connect and connect here. Connect. Simple. Single, direct, you are connecting to a switch. It's easy to configure. Easy to troubleshoot. Why it is easy to troubleshoot? For example, there is a device unable to communicate. Simple, check the connectivity. Check connectivity at a switch. Only you can understand is a device problem, connectivity problem, or a switch problem. Simply by LED status, you can get it. So if there is LED blinking is there, I will show you that one. And not this switch, network switch. When you say switch, so always put a network switch. This is LED status are there. By this LED status, we can understand. So connectivity is there or not. Okay. Link status and connectivity status, you will both are there. So like you can see, link LED, activity LED. Okay. So what is the link status? That is connectivity is there. Somewhere it is blinking. Like see it is blue, orange kind of stuff. Okay. Link LED means connectivity is there. So activity LED, so transmission is going on. So if you miss this LED status, so you will understand there is a cable problem or maybe there is a device problem. Okay. So this is how it is connected. See, this is a search that connected to router, bulb. Now this entire overall Ethernet. Different type of switches. Home based switches are there, manageable switches, non-manageable switches. Okay, in a data center, this is how cables are look like. Okay, so here it is. Once again.
Yes, sir. One question, sir.
Yeah, tell me.
Sir, why this all data centers looks like this messy, sir? I don't understand.
It is not that messy. So they will manage. They will put a clear cut bunch like this. This is not messy. So it's a clear cut is there. But once it is disturbed, it look like more messy. Okay. So some people for supporting. So it is security reasons. People will confuse. Any new person came, they will confuse. They don't touch any cable. Okay. They don't try to hack. But the data center itself is a secure place. It's not unauthorized person cannot be allowed inside. If they allowed, for example, I am allowed to go inside data center. One of my friend or a colleague. So he said, so can I come? So both are working in same organization. So I said, okay, no problem, come with me along. Some issue is occur. Even the issue is not occur. There is a big problem for both of you. Okay. If issue is occur, it is big problem for organization. Because CC cams also there, no? Not that reason. So some people, sometimes it is, they will disturb the network cables. If they don't do the cable management properly, so this will happen. Generally, any data centers will do proper cable management. Compulsory. It is. Every cable has a labeling. Okay, so and color coding also given. So in particular type of communication means server connectivity, router connectivity, 1 Gbps connectivity, 100 Mbps connectivities. So they will use different type of cables, patch panels like you see, different patch panels, and each one having a numbering also. So we can understand what is this, where the cable is connected and where end cable is going on. Because when you are connecting end cable to your system or your wall mount, okay, but original cable connected to somewhere in the data center or a switch place, right? So we should know which cable it is. If you got an issue, so you can able to identify which cable it is. Because in this bunch of cable, no one knows which cable is having which end. Okay, so that is the thing. Okay, good, good question. You guys, this is star. Here it is switch and these are devices. For example, these switches are having a limited number of ports. You can see these are the switches having a limited number of ports. 8 port switches, 16 port, 24 ports, 72 port, 48 port switches are there. For example, in my organization, I have a 24 port switch and 20 computers. 20 computers, 24 port switch. Enough, right? 24 connections you can make it, but I have 20 computers. Good. In case 10 more computers are added. 10 more computers are added. So earlier I have 20 computers, 24 port switch. Good. Now 10 computers are added. So what I have to do it? I cannot remove the old switch and buy a new big switch, right? So I have another switch which is capacity is 24 port switch. Okay. So another computer. So remaining that new devices I will connect it to another switch. Okay. New devices connected to another switch and make a connection between these two switches. These two switches. Hub or a switch, you can connect. A right switch only. Hub or a switch, you can connect. See, there is a connection. So you can make this connectivity as thick connectivity. This. Just for understanding, our understanding. Okay. So it is switch to switch connection. So all these devices will happily communicate each other. Okay, they will communicate. So it is a single topology, single segment. If I don't connect like this, it is a two segments, two networks. Now it is single network only. Okay, it's not internetworking, but it is same network, same physical network. Okay, and it is network only. Okay, so single segment. So this device is able to communicate this device now. Okay, so it is called a scalability. Till now, it is for all the topologies, scalability is more difficult. Now it is easy to scale. So what is the star topology? There is a centralized device. All the devices are connected to the centralized device called a hub or a switch. Called a hub or a switch. And devices will communicate each other. Devices will communicate each other through the centralized switch only. Centralized device only. It is hub or a switch only. Okay. And it is easy to configure, easy to troubleshoot, easy to scale. How it is easy to scale? We can extend our network by adding some other switch or hubs to the network. If you connect both the things, then automatically, so our number of devices we can connect. In our organization, there is a lot of systems are there. No, some organization having 100 computers, some organization having 300 computers, 500 computers, 1,000, 2,000, entire building. So having a connectivity. So there is a hundreds of computers are connected. How they can able to connect and communicate? So because of star topology. Easy to configure, easy to scale, and easy to troubleshoot. Again, if any cable or a device is down, only that the connected device or a down device is not communicate, remaining communication is going on. Okay, but centralized device is down, the total communication is start in star topology. And if you are able to connect, so if you are connecting one centralized device to another centralized device, it is called a extended topology, extended star topology. This is extended star topologies. By using extended star topology, you can scale our network size. You guys understand up to here? Up to star
Yes, sir.
topology. Okay.
Yes.
All points are very important to understand and things. Next topology, hybrid means is a combination point to point, point to multi-point, and a tree topology. So those are normal. If you connect a PC to another PC directly, if you are connecting point to point topology, you have an organization and there is a exit device for a internetworking device. There is a router in your head office. In your corporate office, you have another router. Connect both the things. This is also point to point, point to point, direct connectivity. If you have a switch and you have a devices, of course, this is star topology, but star topology or bus topology, ring topology, there is a point to point, always point to point. This is simple point to point, like a system to system, system to any other device. The connectivity it is one-to-one connectivity is called point to point. And also you can say from one device, one network to another network, we can connect point to point. So this is one separate network it is. For example, this is my branch head office. This is someone branch office. So through WAN connectivity, point to point connectivity. Point to multi-point. This is my main corporate office, head office, where my all the networks such as data center, servers, everything is there in this office. And I have a multiple branch offices in different locations. Through the WAN, I can able to connect from here to there. I will going to share the data, right? These are all branch offices. So this is my main corporate office. I have a data center, servers, everything is here. And this should be accessed through our branch offices. Okay, so point to multi-point. Point to multi-point computers. The last one is tree. Some people asked me about what is the tree topology. That's why I kept this picture. Really, I don't mind about tree topology. Okay. So what is a tree topology? It's a kind of hybrid topology only. So these are all hybrid topologies only. Full mesh topologies and all these are hybrid topologies. But you can see this tree topology is a clear-cut hybrid topology. There is a backbone wire cable. Backbone cable means bus topology. Okay. And to the backbone cable, there is a small network. See, it is something like a star topology is given here. And this side, a star topology with extended star topology. Their server directly connected to the backbone cable. Okay, it is a kind of hybrid only. So in a tree topology, just like a tree structure, there is a stem is there no, in middle. So like that, there is a backbone cable. From that one, so multiple topologies are occurs like a branch type. Okay, so this is a tree topology. Guys, understand what is bus, ring, mesh, star topologies, what is their advantages and disadvantages. Up to here, good. So we discussed what is a network, networking, internetworking, what is different physical topologies. So I will tell about what different type of networks. Then we'll take a break. Then we'll go for a further kind of stuff. Okay. So different types of network depends upon geographical range or a size. Geographical range or a size. So these definitions depends upon the old textbook kind of concepts only. Okay, that is area means geographical size wise only. The original definitions means the real definitions are differ from this area wise definitions. But first of all, we'll see. So local area network, campus area network, metropolitan area network, wide area network. These are the four area networks as from the standard textbooks. Nowadays, there is some other area networks also included in this certain textbooks and some internet materials. Of course, from that one, I like to, so added those two here. Okay. Some people put what are the names in that one. Okay. So here it is. Understand local area network. Already I told a simple LAN network it is. So here it is. To take a building in a geographical area kind of stuff. Your network can be the size of a room or can be the size of a floor. So entire floor can be your network in a geographical range or to the entire building. So in the building, you have a network. So you have a your office is in multiple floors or maybe entire building is your office only. For example, you take big offices like a TCS, very big organization, big offices, right? CTS, HCL. This entire building is belongs to a single organization, one single. This entirely a single language. So a single room, you can set up a LAN. In one single floor, you can set up a LAN. Or multiple floors, you can set up a LAN. An entire building, you can make it as a geographical range as a LAN. But reality, the LAN represents simple local area network. You have a computers, you have a devices, and you connect these devices together either wired or wirelessly. You're connected. These devices is called a LAN network. That's it. Okay. So some people may ask that LAN contains internet or not. LAN does not have internet. So this is not internet part. It is simple local area network. It is your private network. It is your private network. Within the LAN, you can communicate each other. Outside of the LAN, you cannot communicate. If you want to communicate outside of LAN, you need a WAN or a public connectivity. Means outside connectivity is required. You have internet. If you take an internet subscription, then you are connected to internet. So then for your LAN, internet is accessible. Just in a home, you have internet connectivity. Okay. So you have internet for your LAN, you are getting internet. If you don't take internet from outside, you cannot connect. It's a simple private network. Guys, understand LAN? LAN sizes can be a single room or a single floor or multiple floors or entire building is a logical, that means geographical area wise. What is LAN? Local area network. Next. CAN, campus area network. What is campus area network? Sorry, my designing is wrong. Guys, what is campus area network? What is meant by campus? What campus having? In your college campus, what are there? What is the things are there? You have ECE department, CSC department, okay, MBA department, mechanical department, principal office, right? Different buildings are there. All these buildings think like a LAN, ECE branch LAN,
Yes.
okay, another LAN, another LAN, okay. These are the different buildings. Each building geographically, you can say it is one LAN network. Think like this. Not only college campus, university campus, uh, organization like a Tech Mahindra campus, CTS campus, TCS campus, Wipro campus. Means it's a large, like I have went this Tech Mahindra so many years back, that big campus. So buildings, different buildings, we can be able to confuse. Only it will take at least 3-4 days to understand. Then I went to other company campuses in Bangalore. Okay? So that's like lot of buildings. Think like this, each building one lab. And combinedly, if you are connecting all these lands together, and now it is become a CAN, campus area network. Within the campus, we can communicate. For example, CSC people develop an application. It is useful for some information required for your ECE department, or maybe some information we are communicate and we'll get some information from mechanical department. Okay, so within the department, LAN communicates, but from different LANs, we are combined together and we can share information. We can able to communicate each other. That is called CAN, campus area network. So I'm telling in geographical region. Next one is metropolitan area network. In a metro cities. So currently they're like in Delhi, Kolkata, Mumbai, Chennai. These are the main 4 metropolitan cities. Maybe in future, or Hyderabad, Bangalore. Okay, these are cosmopolitan cities, and maybe in future they will become a metropolitan cities also. Okay. Of course, almost all Hyderabad is also become a metropolitan cities. Okay, because that Hoda name changes. Okay, in the metropolitan now we don't apply this to our metropolitan cities. Maybe MTNL, Mahanagar, Nishpat. No, not Nishpat. Yeah, BSNL, Bharatiya Sanchar Nigam Limited, right? So this is MTNL, Mahanagar Telecom Nigam Limited, like that it will comes. Okay, that is only in Mumbai, Delhi, Kolkata kind of stuff. Okay, so what is this MAN, Metropolitan Area Network? So in a cities, within the city, there is different departments, people, officers, so many people are there, right? So what are different departments are there? So for example, there is a hospitals. There is a LAN. Hospital, entire hospital building is connected to LAN. 5 department is there, one LAN connected. R&D, roads related department is there. That is a building is LAN connected. Mayor office is there. Okay, that is also a LAN. Okay, a court, law and order department is there. No? So means the court department, law department. Like a different departments in organization, including industries, transport departments, bus department, railway departments. So different departments and different people in the organization, in the city, able to communicate, exchange the information. So why needed they communicate? They were able to communicate and exchange their information, share information. Information is there. A fire accident is happened. So Not only fire people, hospital people is required, and police is required, law department is required, mayor is also required, R&D is required, forest department is required if in case many trees are involved in it. Okay, so they can share information. So what are their observations? They can share information. So why this fire is occur? What are the effect? How many people who cause this reason and all? So they can able to easily share information. Okay, so what is a MAN? Metropolitan Area Network within the city. Okay, not only department, right? People in the city, different departments in the city can able to communicate in this within the city. The geographical limitation is within the city. So what is this WAN? WAN in our Hyderabad we have a 70s. Of course, in Pune also we have a 70s. Okay, it's a branch office. In a New Jersey, I have a 70s. In Melbourne, I have a 70s. In California, I have a 70s. Okay, so geographically, there are locations, different places. I able to connect these things and communicate. For example, this is India, and that one it is Hyderabad, and this is Pune. Earlier, we have a branch in Pune. After Corona, so not required. So we closed it. It is New York. This is London. This is Australia. Okay, so different geographical locations. I have my branch offices, head offices, corporate offices are there. They have their own setup is there. So I can able to communicate from Hyderabad private network, LAN network to New York network in a different geographical locations are there. So how they will communicate? Through the WAN connectivity. Okay, what is WAN? Wide area network. So this is a private network. This is another private network. Both are in different geographical location. So they have a connectivity. They can have a connectivity over the WAN. So what is the WAN? Wide area network. It's a global, geographically different locations. We can connect and communicate. WAN over public, that is internet. WAN over public is internet. WAN means connecting different private networks, different private networks geographically separated. Of course, using service providers are there. WAN service providers are there. Hyderabad office servers can able to connect and communicate New York office, their servers. Okay, so there is a connectivity. So different private networks globally separated, we can connect and communicate. That is WAN connectivity. LAN within an organization. LAN is within an organization, within our private network is a LAN. WAN, communication between different private networks globally separated, geographically separated. So different administrations. LAN is generally called as a single administration. LAN is single administration. WAN is means WAN is a multiple administration. This is one administration. This is another administration. Okay. So what is again types of networks are LAN, CAN, MAN, WAN, local area network, campus area network, metropolitan area network, wide area network. Okay. So other than that one, guys, there is some more ANs are there. Personal area network, which is I like it because your personal things, your Bluetooth watches, Bluetooth earphones, mobile hotspots, Wi-Fi direct mobile direct connectivities like a printer connectivities you are getting, smart watches. You know These are all we are able to connect together. Smart clothes are there. For personal, with one person, me, my mobile phone, my Bluetooth earphones, my Wi-Fi hotspots, my laptops, like that. So I'm connecting my devices, my person, my shoes, my watches, my belt, my specs. Okay. So this is entirely one single person-wise connectivity. It's a personal area network. Home area network is home automation. Home area network is home automation kind of stuff. Smart TVs, smart LEDs. So you can turn on or off LEDs using your mobile applications, like through Wi-Fi you can able to connect, right? Smart TVs are there, smart ACs are there, smart home appliances, Alexa. These are all by voice command also you can control your home kind of stuff, right? Within the home, the appliances you can connect and control through your voice commands or mobile applications, right? That is home area. That is also I like it. So many other BAN, so many are there. BAN, yes, so many are there. It is not okay. And next one is guys, SAN, storage area network. Of course, people have that in area network. They put a thing into here, but originally for LAN, CAN, MAN, WAN. And that two, only two are important. One is LAN, another is WAN. LAN and WAN, both these two important. Remaining are just manufactured things. Okay. So even the storage area network is a real network. Personal area network, home area network, not a real network. That is manufactured names. It's a network, that's it, personal and all. But I like it, that's why I kept it. Storage area network is a real network, but it is not our home or a office or a organization related. It's not related to that one. It is enterprise. As I said, I have a head office. In a head office, I have a storage servers are there. Storage devices are there. I make them connect each other. Okay. And for redundancy and storage access purpose. It's purely storage purpose only. It's purely inside enterprises. Means not a small businesses, not a home purposes. It's purely in enterprises and storage access purpose only. We use this storage area network. It's not a LAN type, not a WAN type, not a campus area network, not a metropolitan area network. Nothing is not like that. It's not connecting different devices. It's all about connecting storage servers and storage devices only. Okay. It's not exactly type of network. Once again, guys, LAN means within the network, local area network, it's your private network. CAN, campus area network, MAN within the city. CAN within the campus, MAN within the city. WAN is global network. So globally we can able to connect it. So we can connect in the public. Okay. So one word I want to add it here, that is one private to private, not within the private. Private to private, geographically separated. Private to private network. Geographically separated or globally separated. Public means WAN over public is called internet. Okay, what is internet? Anybody? What is an internet? Networks of network. Guys, understand LAN, CAN, MAN, WAN, local or private, CAN within the campus, MAN within the city, WAN the global side. Guys, anybody respond, please?
Yes, sir.
Yes, sir.
Here is a point. What is intranet? What is internet? What is extranet? What is internet? What is intranet? What is extranet? Intranet means it's like a LAN, local private network. Intranet, local or a private network. Intranet within the network. I have a server and I have a systems, I have a switches, everything, and I am able to communicate within the network. So that is intranet. What is intranet? What is internet? I am communicating outside. I am open a website. I open a YouTube. I open a Facebook. So how can I able to communicate? Facebook server is not here. Okay, YouTube server is not in my network. Okay, somewhere it is located, right? Somewhere globally it is located. It is not in my home, not in my private network. But how can I able to access? Over internet. Without internet, we can't communicate. We cannot see Microsoft Teams. Original Microsoft Teams, we are using application, client-side application. The server is in somewhere in the global. It can be in Mumbai, it can be in Hyderabad, it can be in Chennai, it can be in New York, it can be in Singapore, it can be in Malaysia. Okay, so global places. Okay, so internet is used to communicate when you want to communicate outside of your private. You want to communicate any public network, publicly available resources you want to access. So we need a internet. What is extranet? Okay, so what is extranet? Extranet is like a WAN connectivity type only. Means already I told I have a private network and in my organization, my another branch office, there is a intranet. In my office, I have internet. There is a intranet. Means LAN and LAN is there. You try to make a communication between these two LANs is a extranet. You can search it once you've done the class, guys. You can search what is internet, what is intranet, what is extranet. It's outside of private network we are access. And of course, there is a VPN concept is also there. Right. Yeah, this is SOHO part. I will stop up to here, guys. From here, from SOHO. So I will explain each and every device there work, and also we'll see the cable part, remaining things like different concepts are there. So like what is NIC, what is different cables we use it, different switches and all. Okay. So take a break. So how much break you want it? So 15 minutes is okay.
Yeah, sir.
Yes, sir.
Back in 12:25. So we'll take another 40 minutes, 15 minutes.